right, so in this video, we're going to be looking at solving system of linear equations by the addition method. And so the addition method, we call it addition. Sometimes you'll hear it called elimination, but the addition or elimination method is going to be where we add up the linear equations in columns, so top to bottom. And then because of the addition method, one of those variables is going to cancel out. And so what we see down here is this definition of additive inverses. And so additive inverses mean when you add those two numbers, they go to 0. So one example would be 2 and -2. So 2 plus -2 is going to give me 0. Therefore, if I had the variables 2x and -2x, those would cancel or give me 0. Same thing with 3x and -3x. So the goal of the addition method is going to be to get the variables to cancel. And the way we're going to do that is by having the same but opposite coefficient. And so with that, if I can multiply through by something to get the same but opposite coefficient, then when I add these, they will cancel out down the column. And so there are your steps on the screen. I would take a second to pause the video and jot those down. All right, so here's our first example. So before we do anything, we have to make sure that the x's and the y's are lined up. Well, thankfully, this example, the x's and the y's are already lined up, but if not, we will have to do some rearranging. Now we're going to look down our columns and see, is there any variables that cancel already? Because if that's the case, I don't have to do anything with multiplying through. I just can go straight to adding down the columns. And so I've got our columns here. And so when we're looking down that list, I've got x and x. Those don't cancel. Positive y and negative y, those are equal signs. Equal numbers but opposite signs. And then 13 and 5. So the addition method says that you can add down the column. And so I've got here 1x plus 1x is going to give me 2x. Adding down this next column, positive y plus negative y, those are going to cancel. Carry down my equal sign. And then 13 plus 5 is going to give me 18. And so what I've done is added down the columns in hopes that either the x or the y cancels. If not, then when I add them, I'm still going to have x's and y's. All right, so now that I've added down, I got 2x equals 18. I want to solve this for x, so divide by 2, and get x equals 9. Now, I'm not done yet. I still am looking for a point, so I need to back sub x equals 9 into either equation. It doesn't matter which one you pick. I typically just pick whichever one looks easier. So in this one, I don't have to deal with a negative sign, so I'm just going to pick the top one. And so I'm going to plug in 9. 9 plus y equals 13. I'm going to subtract 9 from both sides. And that's going to give me y equals 4. And so my my point is going to be the point x comma y, 9 comma 4. And so that would be the point I would type in. And this is one solution because I actually got a point. So I've got another example off to the right. What I want you to do is write this down, pause the video, and then work through this problem. All right, so now that you've got an answer, if you can check this to see if you got the right answer. So your solution should be 8, 5. I'd recommend pausing the video again just to check through that and make sure you got the correct answer. All right, example 2. So example 2 says 2x minus y equals -6 and -x plus 4y equals 17. And so again, I'm looking through on my columns to see, is there any variable that I could cancel. And so I'm going through, looking, comparing all of these. Well, if I just went ahead and added them, I don't have any variables that would cancel out initially. However, here's the new part. I can multiply an equation by something, or both equations, by something in order to make the coefficients cancel. So if I wanted to cancel out the x's, I need to make this -1 a -2x, because then that is going to make these cancel. And so what I need to multiply everything by, I need to multiply the left and the right by 2. If I do that, now my x's are going to cancel. You could have decided to cancel the y's. If you did that, you would multiply both sides by 4, and then that would make the y's cancel out. But we're going to do the x's for this one. And so 2 times -x is going to give me -2x. And then 2 times 4y is going to give me 8y. And 2 times 17 is going to give me 34. I'm going to carry that top equation over. Okay, now if I have multiplied correctly, then my variables, the variables I'm canceling, the coefficients of those variables will be equal but opposite. So equal numbers but opposite signs. So 2 and -2. And so that's good. That means I've done it right. All right, so I'm going to go to adding down the column. So 2x plus -2x is going to cancel. The next one, I've got -1y plus 8. That's going to give me positive 7y equals. And then in the last column, I've got -6 plus 34, which is going to give me 28. I'm now going to solve for y. So divide both sides by 7 and get y equals 4. Not quite done. I have to find x. And so I'm going to back sub y equals 4 into either equation. I'm going to pick the top because it's got a little bit smaller numbers. But it doesn't matter. So I've got 2x minus y, but y is 4, equals -6. So I'm going to add 4 to both sides. And then divide by 2, and get x equals -1. So my solution, and there's one of them, one solution, is going to be the point -1, 4. Now, putting this back into context, what that means is these two lines, if I were to graph them, would intersect at the point 1, 4. I didn't mention it with example 1, but I can check these. To check, you would plug in x equals -1 and y equals 4 to both equations and make sure it's true. And so I would plug in x and y to both of these equations and make sure that this equal sign ends up holding. That's how I would check these. If not, I would see that somewhere a sign went wrong. Okay, so just like before, pause the video, write this problem down, pause the video, and then check your answer. All right, so here's the answer there. So if you need to, pause again, but you should have gotten an answer of 4, 0. Okay, example 3. X minus 3y equals -2. -3x plus 9y equals 5. Okay, so I'm going to add down the columns. Now, upon first glance, none of these actually cancel out. But I can multiply this top equation. Let's get rid of y this time. If I want to cancel out the y's, I can multiply this top equation by 3. And so I'm going to multiply everything in the top equation by 3. So 3 times x, 3x, 3 times negative 3y, negative 9y, and 3 times negative 2, negative 6. Carry everything down. Okay. I'm going to add down the columns. So 3x times 3x plus negative 3x is going to cancel. Next one, negative 9y plus 9y. Oh, that's going to cancel too. And then the last one, negative 6 plus negative 5, negative 6 plus 5 is going to give me 1, which now we're seeing a different scenario. Well, everything went away on the left, so I was left with 0 equals negative 1, and that is not true. So here's that same chart from last time. If the variables go away and you are left with a true statement, it's going to be infinitely many solutions. Most commonly here, the true statement you'll be left with is 0 equals 0. If you are left with a false statement, 0 equals any number, that will be your no solution. So looking back at this example, 0 does not equal 1. So since that's a false statement, my answer is going to be no solution. All right, so here's another example for you to try. Before I tell you to pause the video, this one you're going to have to actually get into standard form first. And so what you're going to do is minus 2x minus 2x, and then you'll have negative 2x plus y equals 15 as your second equation. Then, my x went away. Then your equations will be lined up a lot nicer and that you can cancel. So pause the video, try that one. All right, so see if you get the same answer, and if you need to, repause and check that again. All right, last two examples. So we've got solve the system again. 2x plus 5y equals 1. Negative 4x minus 10y equals negative 2. Okay, so what I need to do is multiply one equation by something to make the coefficients equal but opposite. So if I'm just looking here at the y's, then to make these y's, I need to multiply 5 by 2. And then that's going to make it match that 10 down below. The signs are already opposite, so I don't need to do anything with a negative sign. So on top, I'm going to have 4x plus 10y equals 2. And then that other one's going to carry down. Now I'm going to add these. 4x plus negative 4x, that's going to cancel. Going down the next column, 10y plus negative 10y, cancel. So I'm left with 0 over there. And then the last column, 2 plus negative 2, 0. And so here's an example of 0 equals 0. Since that is true, it's going to be infinitely many solutions. Word of caution, a lot of students, anytime the variables cancel over here, they automatically write down no solution. Same thing as the last section. If the variables cancel, you can either have infinitely many or no solution. There is not another option. So just be cautious. If the variables cancel, that does not always mean no solution or does not always mean infinitely many. You're looking for, do I have a true or a false statement left? And then that tells you the option. All right, our last two examples, last one we're going to do together, and then one you're going to try with fractions. I know how much you like fractions. We've got 4x plus 5y equals 14, and 3x minus 2y equals negative 1. So again, remember, I'm looking for a variable to have equal but opposite coefficients. And so when I'm looking at these x's and y's, I don't see anything that I can initially just multiply one equation by. There's no way that I can make 4 match 3 or vice versa, and same thing with the 2 and 5. However, I can multiply both equations by something. So I'm going to go ahead and pick the y's to cancel out because they already have opposite signs, and then I don't have to deal with a negative number. And so what I'm going to do is multiply this top equation by 2 and the bottom equation by 5. And then when I do that, that's going to make both the y terms 10y. So the top will be positive 10y and the bottom will be negative 10y. So I'm going to rewrite these equations. 2 times 4x is going to give me 8x. Oops. 2 times 5y is going to give me 10y. 2 times 14 is going to give me 28. I'm going to do the same thing on the bottom equation. 5 times 3x, 15x. 5 times negative 2y, negative 10y. And 5 times negative 1, negative 5. Now that I've done that, I'm going to go back and do my same process. So I've got my columns. And now I'm able to add these down the rows. So the first one, 8x plus 15x is going to give me 23x. Positive 10y plus negative 10y, that's going to cancel. Let me draw my line in here. And then 28 plus negative 5 is going to give me 23. Now I'm going to solve for this, divide by 23, and get x equals 1. Back sub x equals 1 into any equation. You could back sub into these equations or these equations. I would pick whichever one has the smaller numbers or whichever one looks easiest. So I'm going to pick the very top equation because it doesn't have a negative sign. And so I'm going to plug it into 4x plus 5y equals 14. I'm going to plug my 1 in. And now I'm just solving for y. So I'm just solving this equation all the way down for y equals. And so my solution is going to be one solution, the point 1, 2, x, comma, y. All right, here's a fraction one for you. With fractions, the same is true. You are looking to get any of the coefficients equal but opposite. And so pause the video and give this one a try. All right, so here is your solution. So I multiplied this top one by negative 2 over 3 on the top and bottom. And then that's going to make these x's equal but opposite coefficients. And then you end up seeing this is one of my special cases where I get no solution.